So if there's no questions on the homework, we're going to go on and look at 742. Yeah, well, I'll track it. So 7.42, the last part of 7.4, chapter 7.4, is talking about complex fractions. Now, a complex fraction is a fraction that has fractions on top and bottom. Fractions on top and bottom of the fraction. And we cannot leave a fraction with fractions in the numerator and denominator, or numerator and or denominator. We can only have one fraction. We can't have fractions inside a fraction. Even if this was just 7/4 over 9, we can't leave it this way. Yep. Two ways to simplify it. One is we rewrite it or get it so that we have a single fraction on top, single fraction on bottom, and then multiply by the reciprocal of the denominator, or use the least common denominator to simplify this. So for the first one, we're going to do this by both methods. So the first method is to get one fraction on top and one fraction on bottom. Now the numerator is fine. We already have one fraction on top. However, the denominator has 2. So what we need to do with these two denominators is add them together. Because if once I add 1 over x plus 4 to 2 over x, we would have one fraction on top and bottom, and then we can simplify from there. But for us to be able to add these two fractions together, we need their denominators to be the same. So we're going to have to multiply 1 over x plus 4 by something on top and bottom, and the 2 over x by something on top and bottom, so that the denominators are the same. And we've gone over several ways to do it, especially last week, on how to add or subtract two fractions. Or the main way I look at it, I see what the left side has that the right side doesn't. Now it does have an x in the x plus 4, but that is one whole term. So the right side's missing in x plus 4 on top and bottom. So we're going to have to multiply the top and bottom of this expression by x plus 4 over x plus 4. And the left side is going to have to be multiplied by x over x. Incidentally, the numerator is just going to stay 5 over x plus 4. Because we're not doing anything to it, it's already one fraction. Now this first expression, 1 times x, is going to be x. Now the denominator x times x plus 4, we're going to leave it as x times x plus 4. Because when we add or subtract two fractions, the denominators have to be the same, and when they are, it just stays that one expression. We're not having to combine like terms, we're not having to simplify, it's just going to stay x times x plus 4. Same thing's true with our other denominator, x times x plus 4. Now the 2 on top, we are going to need to multiply it through. 2 times x is 2x. 2 times 8, or 2 times 4 is 8. Questions on how we got here? Well, since the denominators are the same, we can go on and add them together. Now the main denominator is going to be x times x plus 4. On top, we're going to be adding the x into x plus 8. Normally we would put parentheses around it, but for this problem here, they're not going to make a difference. There's not a sign change. There's nothing that's simplified. It's just going to be our x into x plus 8. Now we do have one term on top and bottom. However, the denominator has some simplifying we need to do first. So the numerator is still 5 over x plus 4. And the denominator, numerator, x plus 2x is 3x plus 8 over x times. So we did all of that so that we have one fraction on top and one fraction on bottom. That was the main goal. Questions on how we got to this point? Well, realistically, when we have a fraction, really what we're saying is I'm taking the top expression, the numerator, and dividing it by the denominator. Is really what we have here. We have the numerator divided by the denominator. Which helps us because if we want to simplify this, I'm just dividing two fractions. So we keep the first one the same. We change it from division to multiplication and flip. The second expression. Now I didn't write parentheses for the 3x plus 8, but they are there, the same with x plus 4. Now we just need to multiply. On top, we're multiplying the 5 with x and x plus 4. On bottom, we're multiplying the x plus 4 and 3x plus 8. Questions on this here? Our x plus 4 on top and x plus 4 on bottom will simplify because the 5x and x plus 4 are being multiplied together. Same thing's true with the x plus 4 and 3x plus 8 on bottom. So those will cancel, leaving us with 5x over 3x plus 8. 3x plus 8. No greatest common factor between the 3 and 8, nothing we can do to reduce it. And because it's being added, there's no way to simplify, so we just have 5x over 3x plus 8. Questions on this here? Here or there with method 1? So how do we feel about one of the methods for doing this? Huh? All right, we can do method 2 on this. Same problem. Let's go above it. So there should be space above it underneath that spot. You will not need as much space for this one. There's going to be an extra step we're going to add to it that we're not going to do after this point. It's more to drive a point home. Now the other method is least common denominator. We want to find out what the least common denominator of the denominators of the numerator and denominator are. All that's saying is when we look at this fraction, I'm looking at 3 spots. I'm looking at all the fractions that are in the top and bottom of this fraction to find the least common denominator. Now there are 3 expressions. On top we have x plus 4. On bottom we have x plus 4 and x. So one of the expression that shows up in one of the denominators at least once is x plus 4, yes? How many times does the x plus 4 show up in each of those spots? Once. So we only need it once. Now it does show up twice, once on top, once on bottom. But in each of the denominators that it does appear, it only appears in each of those denominators once. So that takes care of the denominator on top and one of the ones on bottom. Is there anything else we need? Yes. So x times x plus 4 is the least common denominator of this entire fraction. Yes? So what we're going to do is we're going to take that over here and multiply the top and bottom of this expression by x times x plus 4. We're going to multiply the whole thing by it. So on top, we're multiplying our 5 over x plus 4 by this x times x plus 4. There's only one expression on top, so we just have it being multiplied by the one on top. And we're going to do the same thing on bottom. Our 1 over x plus 4 is going to be multiplied by this x times x plus 4. And it's going to do the exact same thing with 2 over x. Questions on this here? Now, we're not going to write this step out every single time. I'm writing this up so that we see that top part of the fraction we're multiplying it by is being applied to everything on top. The bottom part of that fraction we're multiplying it by is applied to everything on bottom. We're not applying the top and bottom of that fraction to the top and bottom on top and the top and bottom on bottom. The top is going to the top, bottom is going to the bottom. Now, when we do this product on top, this x times x plus 4 is over 1. We don't write it because it's not necessarily necessary. It's understood to be there. So really what we're doing on top in the numerator of the numerator is we're multiplying the 5 and the x times x plus 4. Which gives us 5 times x plus 4. Which is really just what? 5x times x plus 4. Yes? On bottom of it, we have x plus 4 times 1, which is questions on this here. Now we still need to multiply the denominators, 2 terms. But does this seem like we've cut steps out from the last one? Yes and no, yes, because once we see it. But if I look at just the numerator right now, do I have something in common on top and bottom of the fraction on top? The x plus 4 and x plus 4 will cancel. Wait a minute, does that simplify the only fraction we had on top? Well, yeah, now it's just 5x. I don't have a fraction anymore. That's the nice thing about this here. If we look at the denominator, here, again, just like on top, it's not written, but it's understood to be 1. So this 1 is being multiplied with our x times x plus 4, which is really telling us that we have 1x times x plus 4, 1 times x plus 4, which is just x times x plus 4, over x plus 4. Again, with our other multiplication, we're going to be multiplying the 2 times our x plus 4, and it's over x. Well, the first expression, just like with the top, the x plus 4 and x plus 4 will cancel. In our other fraction, because the 2x is being multiplied, they're not being added, that x on top and bottom will cancel. And what that leaves us with is 5x on top and x plus 2 times x plus 4 on bottom. Questions on this here? Scroll down just a bit. So multiplying by x times x plus 4, once we multiplied simplified, it removed every fraction in the numerator and denominator. Yes? Now we can say this is finished as long as nothing simplifies further. But the denominator, that x plus 2x, 2 times x plus 4, there's a good chance we might have some like terms. 2 times x is 2x. 2 times 4 is 8. And lastly, x plus 2x is, and this is the same thing we got last time. I think we like method 2 a little bit better. I mean, neither method is, well, both methods work perfectly fine. It's just seeing which one you like better and doing it. I like method 2 a little bit better because we multiply, simplify, we're done. Also, this is the last time I'm going to write this step specifically out. I did this to show us that its multiply ends up just being multiplied by the numerator. We don't have to mess with the bottoms of the fractions on top and bottom. It's only being applied to the numerator of the numerator and the numerator of the denominator. So when we look at the next one, we can figure out what we need to multiply the top and bottom of the fraction by so that the fractions in the numerator and the fractions in the denominator simplify out. So we have 3 denominators in the numerator and denominator we need to look at to find the least common denominator to make those fractions go away. So what's one expression that we need to multiply everything by? X minus 2. Because we do have an x minus 2 in the denominator on top. We do have an x minus 2 in the denominator on bottom. In both of those places, it only shows up one time. So we only need it once. Anything else? X. We have to multiply the top and bottom by x. And we can multiply this out. Now our x times x minus 2 is going to multiply by that fraction on top. Now the denominator of it is still going to be x minus 2. But we're going to multiply that x times x minus 2 by the 6. Giving us 6 times x minus 2. At this point here, I wouldn't really distribute or multiply out much of anything because we do have stuff that's going to reduce or simplify. But also we do have a lot of terms that are being multiplied together at this point. And the more that we try to do all at once with this many terms, the greater the likelihood that we're going to drop something, change a sign, get a term mixed up. Now we're going to do the same thing with the denominators. Now their denominators are not going to change. We're still going to have the x minus 2 and x. Now our 1 times x minus 2 is just going to be 1 times x minus 2. or we understand that that's just x times x minus 2. Our other one, 3 times x minus 2 is going to be 3x times x minus 2. Questions on how we got to this point? Now that we've done that, we can simplify what's in common in the fractions in the numerator and denominator. On top, we have the x minus 2 and x minus 2, leaving us with 6x. First fraction on bottom, x minus 2 and x minus 2, leaving us with plus, because the x and x would cancel, leaving us with 3 times x minus 2. Now the reason we can simplify that x on top and bottom is because it's 3 times x times the expression x minus 2. That x is being multiplied. So we can simplify on top and bottom. Fractions being added on bottom, there's a good chance I'm going to have to combine like terms. So we might need to multiply out just to make sure. 3 times x is going to be plus 3x. 3 times negative 2 is negative 6. X plus 3x is 4x. So we have telling us that we have 6x over 4x minus 6. And we can be done as long as nothing simplifies on top and bottom. We can't factor, we can't reduce. 6x is just 6x. One term, nothing we can do there. 4x minus 6, well, the degree is 1 because x to the first, so we can't have our normal 2 sets of parentheses with 3 spaces doing that. What is our greatest common factor between 4x and 6? 2 goes into both, yes? Now, factoring that 2 out doesn't necessarily mean that anything will simplify, but we still need to factor it out. We still need to simplify if it can be simplified. Because before the 6x and 4x, we can't reduce it because the 4x on bottom is being subtracted by the 6. So here it's considered one term. With dividing that 2 or factoring that 2 out, we now have 2 times 2x minus 3 on bottom. We have 6x on top, yes? Well, we know the 2x minus 3 on bottom is not going to simplify because there's not a 2x minus 3 on top expression to simplify it with. Can we simplify that 2 with the 6? Well, the main way to check is C. Is the 6 and whatever else is on top being multiplied? Because 6 times x is being multiplied together, yes? That 2 on bottom, is it being multiplied? Yes. Is there any other addition or subtraction with it? That 2 outside? No, it's just 2 times that expression, yes? So that means this 6 and 2 can reduce by a factor of. So I'm reducing the 2 out of the top, which is going to turn it from 6 to 3, because we divided by 2. The 2 on bottom, 2 divided by 2 is 1. So it simplifies out completely, leaving us with 2x minus 3. So we have 3x over 2x minus 3. It was because we could rewrite it as 2 times that expression that 2 out front would simplify. Questions on this here? We can see with especially this here, this is a little bit nicer, especially once we move that or remove that step of showing that we're multiplying the top terms and rewriting that whole thing out. Because we still did it, we just didn't necessarily write that out explicitly. Are you ready for the next one? x over 6 minus x over 3 all over x over 5 minus 7/10. This is nice because there's not a variable on the denominators of the numerator or denominator. Actually, I think the better way to say that, there is no variable in the denominators of the numerator and denominators fractions. Because if we look at the fractions on top, the two denominators are 6 and 3. If we look at the denominators, they are 5 and 10. So we're looking at just numbers, 4 numbers. We're trying to see what is the first number, the least common denominator of 3, 6, 5, and 10. You all have a guess of what it is. It is. And incidentally, we actually don't have to look at the least common denominator of 4. We actually only have to look at 2 numbers. Because the numerator is 3 and 6, yes? What is the first multiple of 3 and 6? 6, yes? Because 3 times 2 is. So really, I don't have to look for the least common denominator of 3 and 6. It's just 6. Those are least common denominators. What's the least common denominator, least common multiple of 5 and 10? That's greatest common factor. 10. You're good. Because I mentioned this last hour, but when we look at, just kind of as a note in our head, least common denominator is going to be equal to the biggest number or bigger. We're going up. Greatest common factor can be equal to the smallest number or less than it. Because greatest common factor says what's the biggest number we can divide everything into. Least common multiple, what is the smallest number we can turn everything into? Least common multiple, we're going up. Greatest common factor, we're going down. 3, 6, 5, 10. Now, if we did this by looking at the factors, well, 3 is prime, so it doesn't factor. 5 is also prime, so it doesn't factor. But 6 is 2 times 3. 10 is 2 times 5. So our least common multiple, least common denominator, we can use the factors here. I'm going to look at 2's first. Multiples of 2, or factors of 2. And take whichever one has the most factors, or that many number of 2's, out of all 3. Or put it as a part of the least common denominator. Well, our first number 3 has 0 factors of 2. 6 has 1. 5 has 0. 10 has 1. It does show up in 2 different places, but in each of the places it shows up, it only shows up once, so we only need it. Which factor do we want to look at next? Doesn't matter. 3? 3 has 1. Factor of 3. 6 has 1. 5 has 0. 10 has. So even though it does show up in 2 different places, it only shows up once. So we only need it once. Our next factor is 5. 3 and 6 have 0 factors of 5. 5 has, 1. And 10 only has, so we only need it once. Are there any other prime factors to look at across these 4 numbers? No, because 2, 3, and 5 were the only ones that showed up, yes? Which means we need to multiply them back together to see what the least common denominator or the least common multiple is. We can do 2 times 3 times 5, or 3 times 5 times 2, or what's 2 times 5? Times 3. I mean, we could do 2 times 3 is 6, 6 times 5 is 30. I like multiples of 10. 2 times 5 is 10, 10 times 30 is 30. So that tells us I need to multiply the numerator and denominator of this fraction by 30. Now when we multiply it on top, 30 times x is 30x over 6 minus 30 times x is still going to be 30x over 3. We're going to do the same thing on bottom. 30 times x is going to be 30x, but this time it's over 5. 30 times 7. What's 3 times 7? And we just have to add a questions on how we got to this here. In the numerator, 30x over 6, 30 divided by 6 is 5x, minus 30x divided by 3, 30 divided by 3 is 10, still have our x. 30x divided by 5, 30 divided by 5 is 6x, and 210 divided by 10, 5x minus 10x. 5 minus 10 is -5x. 6x and 21, are they like terms? Is there a greatest common factor? 6 is divisible by 3. 6 divided by 3 is going to be 2. We solve our x. 21 divided by 3 is almost 7. There you go. Yep. So we needed to factor it because there's a greatest common factor there, yes? Now we need to see if something simplifies on top and bottom. Now we do have 2x minus 7 on bottom. You have a 2x minus 7 on top. No. So that's not going to simplify. The only thing other than it on bottom that could simplify is 5 divisible by 3. No. So this here is our final answer. Now there's no reason to multiply the 3 back through because it didn't simplify. To rewrite it as -5 over 6x minus 21. Leave it here. This is the final answer. Questions on this here? Now really, sticking with this least common multiple or least common denominator is very helpful because anything we add on top of it or more than's needed is going to have to be simplified right back out. Because if I multiplied on top and bottom by 60 instead of 30, what did we do? We multiplied 30 by 2. We have an extra factor 2. 60 is a common multiple of 3, 6, 5, and 10. It's just not the least common multiple. Now what that's going to do, instead of 30x on top in the 2 spots, we're going to have 60. Instead of this being 30x, it's going to be 60x. Instead of 210, we're going to get 420. So we can see that the factors did go up. Instead of 5x, 60x divided by 6 is going to be 10x. 60x divided by 3 is 20x. On bottom, 60x divided by 5 is going to be 12x. And this is going to be 42. Erase this. Now 10x minus 20x is negative 10x. 12x and 42. 12 does not go into both. so we can just use this here. Because 42 divided by 12 doesn't work. But 42 is divisible by 6. 12 is divisible by 6. So the greatest common factor on bottom is 6. And when we did this the first time, we said there was nothing in common on top and bottom, nothing we can do. But now 10 and 6 have a greatest common factor of, which I'm going to have to factor out, which does get us back to the answer, yes? But to get here, I had to take that extra factor on 2 and bottom back out, yes? Well, what did we do here? Really, we just are multiplying by 30 times that extra factor of 2 I added at the start had to come right back out at the end. So really, I'm using this to drive the point home. If we can find that least common multiple, it makes things easier on us in the long run, because any extra factor we add on top and bottom is going to have to come right back out at the end. Does that make sense? Last one we're going to do today. Yes. So we looked at this here. We have 2 over x minus 4 all over 2 over x plus 3. How many denominators in the numerator and denominator do we have? 2. We got one on top and one on bottom, yes? And the whole process, or the whole reason we're multiplying by this least common denominator on top and bottom, is to get the fractions in the numerator and the fractions in the denominator to simplify out, yes? The 4 on top and the 3 on bottom, do I worry about those or try to figure those out? No, because are they fractions? No, so there's nothing I'm needing to do to simplify them out. Now, they're still going to be a part of the multiplication process, but finding what I need to multiply the whole thing by on top and bottom, I'm not looking at the 4 and I'm not looking at the 3 because they do not have a denominator other than 1. So the main thing I'm looking at is what do I need to multiply the 2 over x by to get that fraction to simplify. So we'll definitely need an x on top and bottom, yes? Do we need anything else for the denominators 2 over x? No, it's just x. It shows up once in both spots, yes? Only way I would need something different is if, say, the denominator was x squared. We need 2 of them on top and. Well, oh, you're talking about, yep, here? If, so, what symbol do we have between the two numbers or terms? Yes, because it's very tempting to want to go here and here, and that would work if this was not minus on top and plus on bottom, because really, those are stuck together as one expression. Because if it wasn't for the addition, subtraction on top, addition on bottom, yeah, we can just cross them out. Yeah. Because of that, we've got to multiply through by x to reduce. Now, the x is going to be multiplied with our 2 over x, giving us 2x over x, minus, when we multiply it with the 4, we get what? 4x. We'll do the same thing on bottom. Our x times 2 over x is 2x over x, plus our 3 times x is 3x. At this point here, the x over x will Cancel, giving us 2 minus 4x. Same thing on bottom. Questions with how we got here? Now the denominator, 2 plus 3x, 3 plus 2x, there is no greatest common factor, nothing we can do with it. However, the numerator, 2 and 4x, has a greatest common factor of 2. And this is as far as we go, because even though we do have that 2 on bottom, it's stuck with that 3x because they're being added. Yeah. No, I'm trying to just, especially the x over 2 and x over 2, just, that's very tempting. But because of the plus on top and the minus on bottom, or, well, vice versa, it sticks them together. This 2